You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal. With this episode, we're starting a mini-series on building performance, speaking to architects who are leading the way on closing the performance gap, a crucial stepping stone to net zero.
And I'm Hattie's co-host George Morgan, Director of 1.5 Architecture.
The myth that building performance evaluation is risky is, I think, fundamentally wrong. Actually, building performance evaluation, if you plan for it from the start, it is de-risking the process because it introduces a level of scrutiny to the building that, for example, you get in the Passive House scheme and other schemes that really plan for operational performance from the start.
Today, our guest is Judit Kimpian, the lead author of Energy People Buildings, a book we co-authored together with Sofie Pelsmakers. To mark the book's one-year anniversary, we're revisiting its main messages and talking to Judit about why getting building performance right is absolutely central to reach net zero. This book is for anyone who wants to understand how energy is used in buildings and what we need to do to drive down operational carbon emissions. If you think this is an overly technical topic, stick with us because Judit explains it all really well. To accompany this episode, we have a special Climate Champions listener offer. Courtesy of RIBA Publishing, we have 3 copies of Energy People Buildings to give away. The book normally sells at £45, so this is a fantastic deal. To enter your name in the prize draw, email me, hattie.hartman@emap.com, with your name, job title or affiliation, and your postal address. Please put Climate Champions listener offer in the subject line. That's hattie.hartman@emap.com, with Climate Champions listener offer in the subject line. I hope to have many requests. 1 year on from the book's launch, the route to net zero is more widely understood across the industry. The UK GBC's Whole Life Carbon Roadmap, published last November, sets out the respective contributions of operational and embodied carbon, both non-domestic and domestic, to overall built environment emissions and the need to tackle them both. As I've said before on the podcast and elsewhere, it's fantastic to see the upsurge in awareness of embodied carbon, but at the same time, we mustn't lose sight of operational emissions. With over 20 years of experience in practice and research, including a stint at Foster & Partners, followed by over a decade with IDIS, now AHR, Judit has been at the forefront of building performance research for years. While at AHR, she led building performance studies of 7 buildings, and she knows everything about what goes wrong in buildings to create the performance gap. She chairs the Architects' Council of Europe's Sustainable Architecture Group, where she advocates for EU policies to ensure that buildings meet the climate challenge. And she currently teaches net zero architecture at the Bartlett. In our book, we put forward an approach that embeds performance in the design and construction process from the outset. Understanding how people will use a building must be at the heart of this, hence the title of the book, Energy People Buildings. Going back to talk to people after a building is occupied is just as important as monitoring the energy, the indoor environmental quality, and the systems. And Judit has done a lot of all of this. Each chapter in the book explains a different aspect of buildings that impact performance: massing, thermal envelope, MEP systems, building controls, and finally, a new approach to procurement to give teeth to the process by incorporating building performance into contracts so that the entire project team is incentivized to ensure that the building performs as intended when it's completed. An important point to make right here at the outset is that we like to talk about building performance rather than post-occupancy monitoring, because ideally this process starts right at briefing stage and then is built into the design process from the get-go. Judit, I'm delighted to have this opportunity to discuss the book with you and George, because George is coming at this from the point of view of an architect in practice. So my first question to you, Judit, is what's changed in your view 1 year on since the book was published?
Hi, Hattie. Thank you so much for having me on your wonderful podcast. What's changed? Well, everything has changed, actually, because energy prices have escalated beyond what we have imagined for a long, long time. And every time there is an energy panic, everyone becomes hugely aware of the role that energy plays in our daily life, how much we rely on it to support everything that we do. And what we are going through in terms of the incredible political and tragic upheaval in the east of Europe is just driving this home even stronger than ever. So the cost-benefit balance of investment for energy efficiency has been completely transformed as a result, because the maintenance costs are really excruciating now. There's an additional dimension to that, so there is energy security as well. So it is not just the price, but it's also the availability of energy, which puts it much higher up on corporations' risk management agenda and government's risk management agenda. So returning to your question, how it's relevant to the book, of course, getting the results that you expect is even more relevant and even more important than ever. So you want to be sure that your investment actually delivers the energy savings and the indoor environmental quality improvements that you set out to have, because it's such an important issue.
So Judit, you really have your finger on the pulse of building performance, and a new British standard has just been released. Can you tell us about that and what you think of the implication of that is?
What the standard is trying to capture is how a light approach to building performance and how a more detailed approach to building performance can be standardized and incorporated into contracts and scopes of work, etc. Now, it is very important, I think, to have such a standard, but I also appreciate the challenges of the task, because building performance evaluations are very hard to standardize as such. Depending on what stage of the project you are doing this evaluation and who is doing it and for what purpose, you would be doing something different. And many building performance evaluation experts are wary of standardization and standardizing this process. On the other hand, the industry is really calling for such standards. So I think it's great that it's happening. I think it will probably go through a few more iterations as it's being deployed.
So now we've got the standard. I'm wondering, have we reached a tipping point, and why has it been so slow to get traction? Practices like Archetype, HMM, Foster's, and Hawkins Brown have gotten to grips with it, but even they find it challenging to undertake on many projects. So how do we get around this?
I think the main motivation for doing this has to be clear. When a client is interested in what it is that's delivered as built and in use, then it's almost a no-brainer. But when you're doing a speculative project, it's a lot harder to argue for this, because you're unaware of who is going to be in the building, how it's going to be used. Persuading clients to do it is the most important challenge. And even more than the standards, the most transformative activity in this space at the moment is sustainable finance, that effectively investors will have to report on the sustainability of their investments. And if they're reporting against global standards, then some of the global reporting initiative standards and other ESG standards, which all require an assessment of the resilience of the property, the energy performance of the property in use, etc.
So this is going to come top down.
Yeah, I think also what makes it less clear for architects is that different insurers have different policies around what they cover and what they not cover. The RIBA is very clear that the RIBA's insurers, cover architects for carrying out building performance evaluations. They like to be consulted if a practice undertakes such an evaluation, and they like to see this planned for from the start. So the RIBA is at the moment working on updating its scope of services to incorporate references to building performance evaluation, when it should be done and how it should be done.
I've got 2 questions. So what's the appropriate time frame for monitoring, and how do you assess how much monitoring you need to do on a given project?
The first stage of monitoring is really when a building is completed and handed over. Are all the things that you have defined in your specifications and in your drawings actually in the building? Are the materials that you specified there? Is the configuration of the building the same? Is the airtightness working as you assumed? Is your build-up thermal bridge free as you prescribed? And are your systems in place? Are they linked up? Are they correctly reading what they should? Are they profiled? So are they programmed to work as intended, to come on when they are meant to come on and turn off when they're meant to turn off? Then, if they're supposed to be transmitting data remotely, are they transmitting that correctly? And then you have a baseline against which you can then compare what the building is doing in use. And this as-built, what we often call reconciliation, is a very, very important element of building performance evaluation, because this is the bit that ensures that architects are not liable for discrepancies in performance downstream that arise from things having been built differently from what has been prescribed.
So how does that work? Because it seems like there might be architects worried about opening up cans of worms and they're becoming liable for things that have gone, not as they might have hoped, or kind of opening them up to having to pay for things that have gone wrong. So what happens when something doesn't work as it was intended to have done, and who pays?
Every project in the building performance evaluation program has gone through this process, and I think there has only ever been one litigation arising from a major construction oversight, which would have been very obvious within the first 2 years of operation, regardless. So the myth that building performance evaluation is risky is, I think, fundamentally wrong. Actually, building performance evaluation, if you plan for it from the start, it is de-risking the process, because it introduces a level of scrutiny to the building that, for example, you get in the passive house scheme and other schemes that really plan for operational performance from the start.
So because you know that somebody's going to be testing, is this thermal bridge free, you actually kind of make sure that you've done all the modelling about it in the first place, because you know that you're going to get checked on it later.
Exactly. So in the book we set out what are the indicators of performance that you might want to set out from the start and agree upon with your whole team. Then how do you intend to meet this in design stage, and then what is it that you put into the contractor's prelims and also into the scope of works for architects and engineers to actually deliver this. This becomes a kind of packaged up information that what Bill Bordas often calls the golden thread of information that ties everything that relates to performance into a really legible package that you can then base your building performance evaluation on, so the information is ready. A lot of time goes on trying to trace data back and information back to what the original intent was. And if this golden thread is complete, then that really cuts down on the time and effort it takes to do such an evaluation. What's confusing for a lot of professionals is that the as-built reconciliation is very similar to what you would do once the building is in use for a couple of years. You would first start logging the energy bills, you would then do a thermographic evaluation. And I think what's really important to appreciate is that this first year of a building's operation, what we traditionally call the defects liability period, is a rather unhelpful term. I think it should be called more a landing period, kind of based on the soft landings approach. that would enable design teams to stay with the building during this first critical year to ensure that really everything is in place and is working as intended. A really great example for this is Archetype's enterprise building, which we feature in the book. Archetype have been refining their approach for many years. And it's true that the clients that they have managed to do these with tend to be owner-operators, which is a great advantage. And also, Archetype have been incredibly organized about how they do this. They feel responsible for the building turning out as they intended, and they are really emotionally engaged with this goal, which I think makes more of a difference than one would think. And they have also done a few clever things, really clever things, similar to some of the other projects that we featured in the book, to set aside a certain amount of funds to be able to rectify anything that they found during this first year. So they kind of hold the design team together for this extra year and deploy these funds as needed if there is anything to rectify.
In the case of the Enterprise Center, it was actually 3 years after, quarterly meetings, 3 years on. And they were able to troubleshoot and solve things. And they had set aside a minuscule amount of money when you think of the whole project cost at the outset. So it was earmarked to solve these problems. And I think they had a glitch with task lighting and they needed to spend £88,000 on it. And they had it and they were able to solve it. The lights were going on and off and driving people crazy.
Because things go wrong all the time in every building. A building is a vast and complex thing. There are things custom built for every one of them, no matter how much you standardize things. The products are standard, but the way in which they come together are unique. And so you have to give buildings this extra bit of time to adjust once they are occupied.
What's your take on this, George? You worked in mainstream practice for 10 years before you started your own practice. Does this make sense to you, what Judit is describing?
Yeah, I think there's a bit of an attitude shift needed from just kind of making sure that you're not seem to be liable for any kind of problems to actually how do we, well, firstly, have robust processes to make sure that they don't happen, but also a kind of open problem solving, hey, it's really complicated, everybody's doing their best attitude towards resolving them if they do happen.
You know, it's really interesting you should say that, because one of the main messages that came across in another of the case studies that we looked into in the book, which is a building in Colorado called the Rocky Mountain Institute. And there it was all about a collaborative team culture, but they actually had a financial incentive. Everybody, if there were savings, everybody gained, both in terms of cost and energy. So it was all built into the procurement process. And that's what we propose in this book. We call it a building performance register, where you set things out at the beginning of the process and then you track them all the way through, so that if there are changes, for example, through value engineering, you pick it up immediately that that's going to impact performance. And it's not like down the line when you're trying to monitor a year later and you're suddenly finding something's way out and you don't know why. So you kind of track it all the way along.
That's right. And what seems to be a common thread in all of these projects, that they had this approach built in right from the start. I was going to turn the tables on you, Hattie, briefly, because you have been in charge of bringing together these incredible case studies that were really not easy to find. Why do you think it's so tricky to find buildings that are both architecturally inspiring and perform? And also, do you sense that there might be a change in the sector?
My sense is that many more people are aware of the need to do this. And, you know, I was really heartened to see that in the Letty Climate Design Guide, they've got a whole chapter about this. And the bigger practices which can afford to devote some time to this are doing it and have been doing it. Another of the case studies in the book, Hayworth Tompkins, they decided they need to do this, and they trialed it on the Everyman Theater in order to kind of establish a process, figure out what time and resource was involved on the part of the practice to do this and what they could learn from it. And I think they found it hugely valuable, and now they're going to roll it out to one of their schools. So it's a question of trying it and then refining it and seeing what level of revisitation is appropriate. The Everyman case study is available on the Hayworth Tompkins website, and it explains what worked well and what didn't work so well. And people like Rob Pruitt of Pruitt Bisley or John Christophers with his zero-carbon house in Birmingham have been doing this on small domestic projects for years. So it's possible at every scale, and you learn what works and what doesn't, and what these numbers mean, and also what causes things to go wrong and how you can avoid it the next time around. I think this is just really critical, and it's still not happening enough. That's why we're talking about it on this podcast. I really hope people will get a copy of our book and get their heads around why this is so important. Fionn Stevenson's book, Housing Fit for Purpose, has an excellent primer on building performance at the back of the book, and the RIBA also has free resources to download. We'll put links in the show notes. There are lots of ways to get up to speed on this.
Together with University College London's Environmental Design and Engineering course that I have been doing research with for many years, they have been really, really energetically pushing to carry out this research with industry. And one of the ways they do it is to have PhD students co-funded by industry and universities to be able to go to an extra level of depth. And also many other practices have done this, and AHMM have just completed a research paper that was awarded by SIPSI looking at their Sterling Prize winning buildings. And the conclusion of that paper was that actually it's not enough to just look at energy, but you need to look at indoor environmental quality at the same time. And we talk about this a lot in the book. So this idea of checking that the people that we designed this building for are actually using it as they intended, or it really works for them, incredibly important for our profession. And it's something I sometimes talk about it in the context of UX design. I did my PhD at the Royal College of Art together with art students and design students from a really wide variety of backgrounds, and industrial designers, UX designers, fashion designers, graphic designers, plus fine art students. And I think you were in this atmosphere where you just talk about UX design all the time. It was something completely normal. And so when I practiced architecture, it really shocked me that architects were actually unaware of this terminology. They don't really know what it refers to, and it's somehow missing. So this notion of feedback from users and building on this feedback and how we design for users is really new. I mean, I remember when one of these EU policy papers came out about the heating and cooling strategy for Europe, and someone managed to put in this sentence about the occupants being an impediment to performance. Can you imagine holding your mobile phone in your hand and blaming yourself for not being able to navigate the interface? Like, it's unheard of. And so this refinement, this understanding of what people actually do in buildings, what works really well and what not, and how do you design something so that people use less resources while the building is in operation as well, is quite a new field. But it's a design challenge that I think we can rise to as architects, but it's certainly very exciting.
The UX idea has reminded me of the other day that Guardian's architecture critic Ollie Wainwright tweeting about being stuck all day in this meeting room, sweltering, and everybody's all breathed all the air, but the windows didn't open and nobody could work out how to turn the ventilation system on. And it's like, oh yeah, that's bad UX there.
And unfortunately, it's not atypical. Now that buildings are really rapidly becoming more automated and smart, we tend to forget that smart is only as smart as the people who designed it and how much they were able to prepare for those user scenarios. And if you're designing a building where people won't have time to think about complicated interfaces, then you have to design a building to work simply and work well simply. And if you have a budget to really design an intricate automated system to deliver that so it's properly working and to maintain it and operate it over time with the right level of expertise, if you can budget for that from the start, then that's absolutely fine. But not all buildings and not all projects can handle that, and not all end users are geared up for that.
That's the case of the Bloomberg building that we were just talking about in our last episode with Hanif Kara. George, do you want to ask your passive house question?
Yes, so when you've touched on passive house, when passive house projects are subject to post-occupancy evaluation, they always perform pretty much exactly as predicted, since the performance has been modelled in so much detail in the design stage and the construction carefully controlled on site. But it's not often used on large projects. Would the passive house methodology, with all this technical work up front, be a simpler way to achieve low in-use emissions than using understandings learned from post-occupancy evaluation on a project-by-project basis?
So any standard that has the rigor of design and the rigor of procurement and the rigor of construction and the rigor of evaluation will do that for you. Passive house is a fantastic approach to building, especially in the northern hemisphere. It comes with certain assumptions that I'm not sure I agree with all of them, but it's definitely an incredibly rigorous process to build and to plan for in-use performance. Now, I could challenge you on passive house buildings always performing as intended. One of the outcomes of the building performance evaluation project, the domestic tranche, was to actually demonstrate that airtightness after a few years does diminish quite a lot, like by about a third. And it does diminish in passive house buildings too by about a third. But when you have incredibly good airtightness, that third is barely perceptible. And if you have a much less airtight building, then that third is an enormous amount. So I think I was having this conversation with a colleague the other day, to what extent passive house over designs. It places a very, very big emphasis on the building exposed envelope area, so it tries to make buildings as compact as possible. From my perspective as a designer, it is such an important constraint, because building taller spaces is really good for people. For example, one of the studies we quote in the book, AHMM, when they did the building performance evaluation of their offices, they found that on the lower level, where the ceiling height is lower compared to the taller, the new floor that they built into their offices, the ceiling height is taller there, they have more daylight, they have better views outside. They have the same size furniture on both levels at about the same density. The people on the taller floor and better views, better daylight, felt that they had bigger desks. So I think, architecture is about tricking human perception as well. But
in that example, with taller ceilings, you've got more heat loss area for the same treated floor area.
Exactly.
So passive house would penalise that.
Exactly, and the so-called form factor is a major penalty within the PHBP model. And, rightly so, because heat loss matters. But you could argue that in a super insulated envelope, does the volume really make such an important difference? And is it really worth failing your building for it when you're actually providing extra height for summertime stratification so that the building overheats less, so that you're providing greater comfort to the occupants, and also long-term adaptability, because if you have a taller space, you're able to convert that space to lots of different functions in the future. So your building may last longer. And so there are these assumptions within every model. So I think it's important to recognize what is useful to take away from these different standards and deploy them in all projects.
That's a really good point that doesn't get made often enough, I think. What about Neighbours, which has been so successful in Australia and has recently been adapted to the UK context? Do you think that will make change here?
I think it definitely will in the commercial sector. One thing that's really important to bear in mind about Neighbours is that it's geared very much about building services, so building systems and their correct operation. So it's not so much an architectural tool, but a really rigorous tool for the design and planning and operation of complex systems that commercial buildings often have. I think it's a fantastic initiative, and I hope it will be deployed to as many commercial buildings as possible. How applicable it is to other building types, I think, needs some thought.
So what skills do architects need to be able to undertake building performance studies? So yeah, what would architects do? What would they get specialist input for?
It's a really good question and quite timely for us as well, because I've been involved with UCL in developing a masterclass for professionals. And the masterclass is based on 4 days, 4 modules. And the way we sort of structured the course is to actually give architects tangible skills. So the first day is really just setting the scene, understanding what the legislative drivers are, what is feedback, what does it entail, what you can learn from it, how does it work, so what do you do what is a building performance evaluation, and also looking at benchmarking in detail, so people get a sense of scale of how much kilowatt hours is good kilowatt hours. They learn about the RIBA 2030 targets, the LETI targets, the CIPSI benchmarking tools. That's day one. And then day two looks at what our assumptions are about sustainable design, and then actually understanding what feedback tells us what has worked really well and where we need to do more work. So day two is about fabric performance, understanding what feedback has told us about what really works well in terms of fabric design and what are still challenges, and understanding how to calculate and forecast some of those and plan for those risks. Day three is about services, so how to plan for operational performance, how to calculate it, what systems to consider, and what could be the glitches, and what are the things that you can do in terms of user interface design to improve the operational performance of buildings by designing for easier use and better ways of relating to the systems, not just for users but for facilities managers and operators too. And the last day, most importantly, is on procurement, so procuring net zero. Exactly what you put into briefs, what you put into scopes of works, what you put into the contractor's prelims, and then how that information is then used to evaluate the performance of the building and the ins and outs of liability and what to do about those.
So what are the impacts for procurement on having buildings designed and monitored to such a kind of level? Because sometimes you hear that Passive House doesn't work with design and build, for example, because the contractors feel like they'd be taking on too much risk.
To give you an example, the Keynsham Civic Centre, which AHR designed, when we were undertaking the building performance evaluations, we were at the same time bidding for the design of Keynsham Civic Centre. Bath and North East Somerset Council was an incredibly enlightened client, and they wanted to target operational performance, but they wanted cost certainty as well, so the building was obviously going to go down the design and build route. And it was the first time we piloted this building performance register, and Max Fordham were fantastic at taking it on board and then embedding it into the contractor's prelims, which meant that the contractor knew what it was taking on and was responsible for collecting data, for example, from day one of the building's use. And they were benchmarking this data monthly in the first 3 years of the building's operation, similarly to the enterprise center. But so from the architect's perspective, the architecture team were saying that this was one of the easiest projects that they have ever worked on, because they didn't have to spend all their time in senseless value engineering meetings. The client saved 96% on energy and maintenance costs from the consolidation of their assets, and reportedly the project was on budget.
This just seems like it's so much the way forward. Are you coming across other clients realizing this and this starting to happen?
I think there's a huge demand from commercial clients for net zero because of the ESG reporting requirements. Few clients really understand what that actually means, and it's very useful for architects to be able to speak this language. Many clients who are owner-operators are more aware of the details, because for them it's an obvious de-risking process. So lots of higher education clients. I think the Scottish government is very forward-looking on this and requiring building performance evaluations on all projects. But so basically, design and build, I don't think it's an impediment at all to this process. But it does require a conversation early on, both with insurers, and also the teams need to know what they're bidding for and what's going to happen when the building is completed and whose responsibility is going to be what. And I think, to me, what this introduces is a level of accountability that we normally don't see in construction, which is helpful.
Which Passive House also does to a certain extent.
Which Passive House also does to a certain extent. Bear in mind that Passive House doesn't mandate the measurement of energy consumption in use or indoor environmental quality in use or occupant satisfaction. But they do have an independent entity signing off the as-built drawings and details and require evidence that that's been implemented on site.
So tell us what you're seeing happening on this front at the EU level.
I've been working with the Architects' Council of Europe for the best part of 10 years. There is an enormous investment going into the renovation of buildings. And the thing is, it isn't just performance. There's a support for improving the architecture of buildings in the course of making this investment. So recognizing the importance of quality and performance through the EU Bauhaus and through a scheme called the Levels Performance Indicators, which is not an evaluation scheme, so it's not a rating scheme. It's the first reporting framework that looks at not just energy as calculated, but it looks at a broader range of performance indicators. So it looks at whole life carbon. It requires a bill of materials. It looks at water consumption. So it takes a look at the resources that we use and then compares it with what we are achieving with it. So the indoor environmental quality, the climate change resilience, and also whole life cost and value, which is a much more comprehensive framework to work with. And I think architects have missed the ability to balance all these often conflicting factors. Because each building is different, if an architect is able to plan for these, then you can balance all these different factors and you can design for it. And you can make it wonderful for occupants as well at the same time. So together with the Levels program and EU Bauhaus, it looks like we're at least beginning to talk about the right things. And there is a huge amount of investment going into this, so hundreds of billions.
So on this wider scale of all the buildings we have to decarbonise, there's only so many people with the technical understanding to do it. So how do we roll it out? Do we need simpler guidance or clearer rules?
Well, I think you often talk about education in your podcast series. And the RIBA is really recognising that we need continuous improvement and continuous learning in construction professions, and we need to do it fast, and we need to have really a lot of knowledge and learning in the public domain to share lessons learned, because we need an enormous amount of innovation in a very short period of time, and we somehow need to de-risk this innovation, and the best way to do it is to do feedback and share knowledge.
I think this is really a way forward. Before we conclude, we've written a whole book together, but I wanted to hear a bit more about your journey. How did you get interested in this topic?
I did my PhD in ephemeral, deployable, animated, curved, demountable structures in this incredible, rich, artistic environment, artistic and design environment. And so when I started my working career at Foster's at R&D, I had this approach liking to have evidence-based decisions in design, and also because I had the background in the digital tools, understanding how buildings change over time and understanding how the environmental conditions change around the building, but being able to simulate these situations with digital tools and visualize them and then use these tools to fabricate more complex building form just gave me a really early handle on this whole notion of feedback and how you embed it into the design process. And then later on, when I was running a larger R&D, advanced modeling, sustainable architecture team at AHR, I really wanted our practice to start designing buildings with less impact, and then realized that while we are able to calculate the performance, we have no evidence about how the buildings perform. It was a time when Ed Miliband was appointed to head DEC, the Department of Energy and Climate Change, and they put a lot of funding towards finding out what works really well and what works less well in sustainable construction. And we were really lucky to participate in these research strands and build a collaborative approach to doing this research with academia, with the RIBA and SIPSI and other industry partners. Then the interest came about how you then procure buildings that really perform.
So how does all this fit into the Retro First agenda, Judit?
So I think what's really important to recognize is that where our greatest impact is in the existing stock, that we have to change the mindset of the industry from looking at buildings and thinking what we could build instead of them, and recognize the assets of the existing stock. So interestingly, now if embodied carbon calculations are required in order to be able to demolish a building and build a new building instead, that's great, because keeping an existing building, at least its structure and its envelope, is definitely in almost all circumstances a better option than building a new one instead. But I think the one thing we don't recognize, and it was really clear from your earlier interview with Barnabas Calder, is that the buildings that we have, even the newer buildings from the 20th century and later on in the 20th century, they have a mass in them that we would find really hard to replicate with current budgets and financial and carbon budgets, and with construction methods. And the proportions, so the taller ceiling heights, the shallower floor plates, the size of the openings that many of these buildings have, even things about the width of the circulation areas, is just not something that we would ever build anymore, because we build mean. There's no redundancy in new buildings. And I think it's important to recognize this as an asset, and then when you do an embodied carbon calculation for a new building, the new building calculations should be replicating the existing building's thermal mass, floor to ceiling heights, i.e. the summertime overheating potential at the minimum, in order for those calculations to be a bit more robust. And maybe another really important point, so one of the things we're pushing at EU level, for example, is that the national retrofit strategies, which Letty and everyone I know is lobbying intensively to have one for the United Kingdom, that these national retrofit strategies incorporate low embodied carbon approaches to retrofitting typical building types. The investment that will go into retrofitting, we should use this vast investment to fund the creation of the circular economy. We should fund the creation of local storage and sorting and certification sites for materials that are being disassembled from buildings. We should fund the creation of platforms where people can trade these building materials. We should fund the creation of new materials that are used with recycled and bio-based materials. And we should fund the training of people to incorporate these safely in retrofits, so that we extend the lifespan of the building stock that we currently have.
Great. Thank you. Thank you very much. I think that's a good place to stop. Before we close, remember our special Climate Champions listener offer for a free copy of Energy People Buildings. To put your name in the hat for the prize draw, email me, hattie.hartman@emap.com with your name, job title or affiliation, and your postal code, and Climate Champions listener offer in the subject line. That's hattie.hartman@emap.com. Climate Champions listener offer. our next episode, we'll be talking to AHMM's Craig Robertson about a post-occupancy study of their Sterling Prize-winning Burntwood School in southwest London that Judit mentioned during this episode. It's still quite rare to find high-profile projects with thorough building performance studies that explain not only what worked, but what didn't. Come back in 2 weeks to hear all about it. If you're enjoying Climate Champions, please rate us and subscribe on your favorite podcast platform. It helps people find us so we can build an audience. You can find the show notes for this and previous episodes at architectsjournal.co.uk/podcasts. Thanks for listening.